Okay, we're going to see how the constitutive laws and block diagrams are for the zeros and one junctions. So we have a one junction over here, and what controls the summation of this is actually this half arrows in here. So if we have something, this kind of equation, this kind of graph, is obviously that in this equation you say that all the flows f1 is equal to f sub 2 and is equal to f sub 3, but the efforts will add up this way. One way to remember this is because the summation of all of this is 0, all of the efforts are 0, summation of all, so you could say what comes in equals E1 is equal to what gets out, E sub 2 plus E sub 3. Okay, so having done this, then we have established an equation for writing the block and the summation also. So what you have basically in this case is that if we have the junctions like this, and we have them like this over here. How are the connections here? If all the flows, this is E sub 1 and this is F sub 1 and this is E sub 2 and this is F sub 2 and this is E sub 3 and this is F sub 3, like this, how would this connection be done? So in here you have that this is F1, F2 is F3 are the same. So I will change the color to show you how the connection goes. This will go like this. But in here we have to add this. Okay. And it depends how the signals in this are drawn. This signal will have only one output. It cannot have two or so. But this is the equation. So if this out of a summation point, this is the output like this, then these two are like this. So if this is the case, you're going to have to write the equation in terms of E sub 2, but not a different equation, this one. E2 is equal to E1 minus E sub 3. So if this is the case, E1 is going to be plus and E sub 3 is going to be minus. See? So it depends how, from the connections that you have, how these arrows are drawn. Take a look to see which is the output in here, but you have to go by the equation the way these half arrows do. So write the equation first and then accommodate to whatever you have in the block diagram. So I would like to now maybe try a zero junction with a little bit of a difference in here. Let's say a zero junction, maybe you have them. How about this? We are gonna have all of these guys in, just so that we understand this. And in here what happens is that you have consistent with the other explanation, that if we put this as a 1 and a 2 and a 3, that E sub 1 is equal to E sub 2 to E sub 3. Yeah? So now what you have is this is the Well, let's just do first the junction, the bonds, and you have this in here like this, and then you have it this way. This is your E1, this is F1, E sub 2, and then F sub 2. This is E sub 3, then F sub 3. So in here you have all the E's the same, so I am going to change colors to illustrate the connection again. So here we go. I think we need to make a little correction here because the lines are going to cross, so I don't want you to get confused with this. So the efforts are going to be the same in here, so all this is one in the same connection, like here. That's all. That is this. But also you know that f sub 1 plus f sub 2 plus f sub 3 would be equal to 0. So if you have now on this graph, let's say that you have that this comes in like this, and this other one comes in like this. One of this is going to be the output. In this case the output is f sub 3. So if that's true, f sub 3 is equal to minus f1 and minus f sub 2. And if that's the case, this is f sub 3, which is over here, is f sub 1, which would be a plus, and f sub 2, which would be a minus in this case. And that is the way we will build this second connection, this. So my message to you is this: on the zeros and ones, the connection pretty much is controlled by the way the arrows go in. But when you connect to other elements in here, to the left or the right, those are going to determine whether those signals come in and go out. But that has nothing to do with the constitutive law, which is for the zeros and ones, that in the case of the ones the flows are the same, but then the efforts will add up to 0. If looking at the block diagram, once you connect things, you find yourself that the output is E2, then you have to write the equation in terms of E2. You are not changing anything, but you're just rewriting the equation in terms of E2. And if that's the case, it's E1 minus E sub E sub 2 is E1 minus E sub 3. So E1 is plus, E sub 3 is minus. On this case, I deliberately brought the arrows the other way, and I think we have a little mistake in here, and I realize now. This is a E1, E2, and E3 the same, and then the summation of these three is equal to 0. F sub 3 is minus, I think I put it in there, but I didn't notice very well. Oh, now I need to correct it and do it right. Sorry, this is minus F1. There you go. And if that's the case, we need to correct this too, because I wasn't looking at that. This is minus F1 minus F2, so this would be a minus also, F1 and minus F sub 2. I'm sorry about that small. I just wasn't seeing that the minus sign was in front of this one also. So all the efforts are the same, are signified over here, but the fact that the summation of this is written in terms of f sub 3 as an output, then you have to rewrite the equation to reflect that. Otherwise, your block diagram will be wrong. So you need to put the signs according to what the output is in here, but keeping the basic equation that is actually controlled by the half arrows. So the half arrows control the way things are up in there. The block diagram is written in certain way that one of the signals is the output, because you could have a situation where you could have two inputs and two outputs on a junction here, and then you say, well, then what is the output? The output is going to be determined what happens in the junction once you connect the other elements, and then you're going to have to write it in terms of that output, like in this case in terms of f sub 3, because that's what's coming out of the summation point, and based on the basic constitutive law, which says that all efforts, all flows in this case add up to 0, then you have to rewrite the equation accordingly and determine what signs would be appropriately placed on each one of the elements. So I hope this gives you more of an insight on what is in the equivalence between a bond graph and a block diagram.
I have a question. How do you decide it's F3?
What I'm trying to say is that when you connect these things, you're going to see that one of these is the output. In this particular case, I assume that during the connection this happened, because otherwise we're going to have to make a decision here which one is the output, and I chose to be F3. So if this is the case, F3 has to go this way and the 2 have to come in. See, so and if I do that, then the 2 are negative and F3 is positive based on this equation. Yeah. So I hope that gives you a good insight into these connections.